Hi, welcome back. So we come to our last session of 6 today. Personally, I really feel it's been very, very good presentations. Big thanks to those who've presented today. Certainly helped my understanding, and I very much hope it's helped the understanding of people who've come in and joined us. So for the last presentation, I'm delighted to welcome from Ping Identity Mance Harmon, who's going to be following on the work from Swirled and talking about that in a particular environment that they're working on.
Okay, great. Thank you. I suppose I just push the green button. See if it works. Yes, okay. Well, good afternoon. So for those of you that were in the previous session, you just heard about Hashgraph. You heard about some of the properties that it provides as a distributed consensus algorithm. What Ping has done is built the first application on top of Hashgraph. We have a POC. I'm going to be talking about that. It addresses a problem that we have grappled with in the identity community for more than a decade, 15 years, and I plan to describe all of that to you. So you heard Patrick this morning say that what we need is a kill switch for identity. We need some way of shutting down sessions. So the community has done a great job of building SSO, single sign-on, making it possible to go to work in the morning, log into your SSO server when you get to work, and then from that point forward, log into any number of applications without having to authenticate again, single sign-on. What we haven't done, well, we did do well single sign-on before the world got complicated. And what I mean by that is before SaaS came around and mobile came around with native apps, et cetera, that complicated the picture. There became not just SAML, but any number of approaches, and specifically we settled on OAuth and OIDC. But the session logout function has attempted to be addressed, has been addressed in various forms, but it doesn't work as well as we'd like for it to work. And so why would we want to do a session logout? There are a lot of reasons. Here are just a couple. One, if an employee, if you terminate the employment for an employee, then you might want to immediately push a button and know that the session across all of the applications has been shut down for the employee. Or a device is lost or stolen. You need to push a button and know that those sessions have been canceled out so that the attacker or whomever finds the device doesn't have access to Salesforce or Concur or some financial application, et cetera, right? It's also important for continuous authentication. Patrick touched on that. I'll come back to it. So let's define some terms. When you log in to your SSO server in the morning, you create an authentication session. The SSO server creates an authentication session that represents the session associated with that authentication event, right? You then subsequently go to an RP. Maybe it's SaaS, maybe it's a web app. That application then creates another session. We'll call that the application session. And there may be any number of application sessions that are created as a result of that one authentication session, okay? So if we want to do a session logout, then what we have to be able to do, obviously, is tell the applications, close down that application session. Well, that means we have to communicate with the applications, and there are a couple of ways to communicate with the applications. The first might be through a web browser, as Patrick mentioned this morning, and we call this the front channel solution. In this case, the web browser needs to talk to a URL, typically associated with an application. The application developer sets up an endpoint or URL that is specifically there for session logout. The web browser has a cache. In the cache typically would be a cookie that's associated with the application session. The web browser is directed in some way to the application logout URL. The application sees the application cookie and knows which session then to shut down, does the session log out. But we have to be able to do that across all of the applications. And so how do you do that in an efficient way? Well, a number of ways have been proposed. Maybe you have an iframe for each of the applications that is open. So you have an iframe in a page that's loaded in the browser, and for each iframe, each application URL, session logout URL gets loaded, and you log them out that way. You could do a form post with redirection, sort of daisy chain the bouncing of the browser from application to application. There are other methods that have been proposed as well. The problem, of course, is that this is brittle. If the web browser gets shut down or you're not able to connect to the endpoint, then you may not be able to log out the session. Worse than that, you don't know the state of the system. You may not know whether the session was ever logged out. Also, in front channel solutions, it's typically the case that the user is the one that is deciding to log out the sessions. It's not going to be easy, obviously, for an administrator, an IT administrator, to open a browser on your computer and bounce around that browser, right? That's not the way it works. The user is the one that goes and clicks the session logout button and takes that initiative. If there's a business mandate to, under certain circumstances, log out the session, then you're not going to use front channel. You're going to use the back channel, which is, in this case, it's just a direct API call between the IDP and the RP. The problem with this approach is that somehow you have to have the application or the IDP do the correlation between the subject, the users, and the sessions that have been created for those users. In this case, what I'm showing is that the IDP would send over to the RP, say application 1 there, it would tell application 1, please log out the session associated with Mance Harmon. In that case, the application has to maintain a mapping between Mance Harmon and the session that's been created for me, right? So it's burdensome in some ways on the application developer. You could do it on the other end as well. The IDP could maintain that mapping. Either way, you have to somehow maintain the mapping between the subject and the session. You don't have browser cache, right? The cookie doesn't exist. And so the simplicity that we had in the front channel of knowing which session to log out is lost in this method. Obviously, though, you don't have the native app or the web browser directly involved in the process. So it's possible for an IT administrator to push a button and log out the sessions. So what would we like to have? The ideal solution is that we get the best of both worlds. In front channel solutions, we have a simple way of knowing which session to log out, but we don't have the verifiability that you would get in a back channel solution. In a back channel solution, you make the direct API call to the RP or the application. You know if you've talked to the application and you get a response back. Yes, I received your message. So you have verifiability that the session logout request was sent and received by the application. But in the front channel, we have the simplicity of correlating the subject with the session. In the back channel, we don't. The ideal solution would, of course, include both of these. So how are we proposing to address this problem? You've already heard it, distributed session management. Let me explain how this works. So what you see here is down on the bottom right corner, we have the IDP, and in that security domain, maybe there are a set of relying parties, a set of applications. That would be sort of a WAM context, a bunch of enterprise apps running inside of a security domain. There may be RPs outside of the security domain. So we got some SaaS apps. We have different security domains, just as you would expect in a normal context. It's going to be a combination of protocols we're using SAML. In some cases, we're using OAuth. In some cases, OIDC. You've got native apps. You've got web browsers, different types of user agents. And each one of those is going to share a common database. The database records session information. Now remember, I said that when you log into the SSO server in the morning, you're creating an authentication session. When that event occurs, the IDP, or the SSO server, would make an entry into the session database for that authentication session. When it passes the token to the application, the token contains a reference to the location in the session database that contains the information for that authentication session. Okay? Now, this is a replicated database. We are using distributed consensus to ensure that all of the parties, all of the RPs in this case, are looking at the same database, looking at the same information, and it happens very quickly. Because we're not talking about proof of work or throughput problems that we might otherwise have with blockchain, we're using Hashgraph in this case. We're able to drive consensus through this community of participants, this community of distributed consensus parties. Within seconds, the database is replicated and common across the community. Okay? So the IDP writes an entry into the session database, passes the token to the RP, and then on every subsequent visit to the RP then looks into its local copy of the session database to confirm that the authentication session is still valid. And as long as it is, the flow just continues on as normal. It gives access to the resource, right? If we want to push the kill switch, all that means is that the IDP goes in and it marks that authentication session entry in its local copy of the session database as being invalid. When that happens, that change gets replicated across the community, and subsequently, whenever I attempt to access the resource, the RP looks in its local copy of the session database, it sees that the authentication session has been invalidated, and it interrupts its normal flow. It doesn't allow access to the resource. Okay, makes sense? It's really simple conceptually. In fact, what we've done is we've simply abstracted this communications channel from the identity protocols in some sense and pushed it down in the stack. We've made it possible to we've created a comm channel that's lower in the stack that ensures that the community has common state on the session database. Okay? All right. So once you have this type of infrastructure in place, it becomes possible to think about doing other things that you might not have otherwise considered. For example, we could have a field associated with that entry, that authentication session entry, that has the timeout timer associated with it, the timeout number associated with it. Whenever I sit down at my desk and I want to fill out my travel report, and I'm going to do this when I get home. I want to fill out my travel report. I will open my bank account statement, my credit card statement, and then I will open Concur. I use Concur to fill out this expense report. I'm looking at what's going on in my statement and then entering information into the expense report. Well, my bank is sitting, listening, watching to see if I interact with it on some regular basis. Some It has its own timeout associated with its application session. When I log into the bank, an application session is created for me in that session with that SaaS app, the bank. And for me, it's 15 minutes. And so I'm sitting there working on filling out my expense report in Concur, and I'm not interacting with the bank app. And every 15 minutes, the little pop-up comes up and says, your session is about to expire. Why do they do that? They do that because they're worried that I've left the computer and that somebody potentially is going to sit down at the computer and use that session to gain access to my bank information. They're trying to prevent or mitigate a threat vector. Well, that's a pain, right? That's a pain for me. It's a pain for you. Wouldn't it be nice if my bank could somehow know that I haven't actually left the computer? I'm still sitting there, right? And by having the applications update the timeout associated with the authentication session, when I interact with my bank on some periodic basis, it goes into its local copy of the session database and updates the timer associated with my authentication session. Then I go and work in Concur. The bank gets ready to time me out. It looks to see what the timeout is on the authentication session. Well, Concur is updating it as well. And any application I interact with is updating that same timer. And so we can do session extension by having this common state across applications. We could also think about fine-grained dynamic attributes, updating the level of assurance. Maybe the IDP has a risk engine that is calculating the certainty that the IDP has in my identity, and there's an LOA measure associated with this authentication session. And that LOA can be updated on an ongoing basis. And when I try to access resources in an application, on every request, potentially, the application could look at the LOA and decide whether or not it wants to give me access to that level of resource. Right? You could start talking about these types of use cases. Continuous authentication. So Patrick, again, mentioned this morning. The notion of continuous authentication is that we want to move away from time-bound sessions. Like I'd mentioned with the banking app, it's got a timeout of 15 minutes on a session. And this is common. You log into an application today, and maybe there's an 8-hour timeout on the token, right? An expiry of 8 hours on the given token. Well, if it were possible to maintain a level of assurance in the identity, we can move away from time-bound tokens or sessions to infinite-lived sessions that get shut down by exception, which would be really nice. But if we move that direction, then by definition, we need some way of shutting down the sessions, right? There will be exceptions, and if there are exceptions, then you need to shut down the session. So in the context of single sign-on, when we have an IDP and multiple applications, and we're using continuous authentication, we need the kill switch when the level of assurance drops below some threshold. Okay? And that's what I just described. So the two sort of go hand in hand. Single logout enables the opportunity to use continuous authentication, which of course requires single logout. Make sense? All right, what's the secret sauce? And I've already mentioned it. So what was the process that we went through here? We, of course, thought, well, can we just use a central server? And the answer is yes. You can use a central server as the database. You don't have to use a distributed database. But there are some reasons why you wouldn't want to use a central server. Basically, there's a set of properties that you would like to have in distributed session management that you don't get unless you use something like Hashgraph. But we looked at a central server, we looked at leader-based systems, traditional distributed consensus systems like Paxos, Raft, non-proof-of-work blockchain. Not much has been said about it here, But when people talk about blockchain, they normally think blockchain with proof of work. Well, if you trust everybody and you still want to do blockchain, you can do that. And you can dispense with proof of work, but it has its own set of problems. And we could talk about those. And then proof of work blockchain, which is what most people think of when they think of blockchain, like what you have with Bitcoin. And then hash graph. So this may be an eye chart. I won't go into all the details, but here is the list of requirements that we specified or derived for the distributed session management application. If you're going to build an instance of DSM, these are the properties that you want in the DSM system. Obviously, what you would like to have is certainty that when a session logout request is made, that it is delivered, and you also want to know, as the IDP, you would like to know when it's delivered, and you want proof that it was delivered, right? The IDP sends a session logout request to a bank. It wants to know the bank received it, and that the bank actually, proof that the bank received it. You can't prove that the bank shut down the session, but you can prove that the bank received the request. Okay. Also, if the timestamp on this request is going to have legal consequence, then the bank really doesn't want to trust the IDP to say when it sent the request, right? That's putting a lot of trust in the IDP if it may potentially damage the bank. So you want a consensus timestamp on the events, on the session logout request, for example, so that the bank doesn't trust the IDP. The bank, the community, comes to an agreement on when the IDP submitted the session logout request to the bank. So Hashgraph uniquely provides those two properties. It may be possible to build those on top of blockchain, potentially, probably even is, but it comes with a lot of additional baggage, a lot of overhead that we really didn't want to have to deal with. And I could talk more about these. So that's the story. We have a bunch of resources online. There is a full white paper that describes this and goes through this in more detail. The labs team at Ping has built a proof of concept for this. Thursday afternoon, there is a master class where the actual DSM API is going to be discussed. There will be a demo of using the DSM system to do a single button logout, using the kill switch that kills sessions across identity protocols, SAML, Connect, across client types, web browsers, native mobile apps. And that is, of course, the value of this, the beauty of this, is that it is independent of the identity protocols themselves and can be used by the identity protocols. And that will be demonstrated on Thursday, along with more detail on the API. So the website contains the API. It contains the white paper. There will be code. It's not there yet, but the DSM POC is going to be open sourced so that the community can download that and play with it. There will be the Hashgraph platform that will be downloadable and can be used along with this. The API was proposed yesterday morning to the OpenID Foundation committee, and so that's now in place with them for review and discussion. Also, Ping is interested in talking to those of you that might be interested in partnering with us in helping to explore this. There is a page on the Ping website where you can go and register if you want to participate in the development of this as we go down this path as a community. Go there and you can get that. And that's it. ready for questions.
Mance, thank you very much for a very clear and enlightening explanation. We've literally got a minute or two that we can take a couple of questions, so please.
How do you control who's allowed to throw the kill switch?
That is still a policy question for the IDP.
So you don't?
We don't control who throws the kill switch, no.
One more?
How much of a concern is privacy? It feels that the oversharing of session information can lead to creation of a super
Yes.
cookie, and you can track user activity and so forth.
Yes. So there is always the potential for correlation, but what's being communicated here is nothing more than basically a session identifier, and that's it. It's just a session identifier, some random string, and then when I send the token to the application, there's a reference to the location in the database for that session identifier, and that's it. So no PII or anything like that. Strictly for session logout, there's no additional information that's even being updated by the RPs themselves. When you get into session extension, where the RPs are actually updating the contents or the data structure that's stored in that session database, then potentially you are seeing, it's possible to see that a particular RP updated the timer associated with a particular session. But that's as far as that goes. Yep.
One more?
Just to extend on the same thing, you still, every RP needs to know every other RP in the thing, right? So essentially, one RP knows what all RPs you are communicating to, the same thing. So that is also.
So the RPs only know what's written into the database. When you write something into the session database, it is the case that you're signing it, right? So the IDP makes an entry into the session database. The RPs are going to have the public key associated with the IDP. So yes, they can know that a session has been created by the IDP. But again, if the RPs aren't updating the contents of the data structure, then that's all they know. They just know that a session's been created by the IDP.
Time for one more, sir.
So one of the biggest issues when you build a distributed system is distributed cache coherency. So it's one thing to, when you use the internet scale, it's one thing to call an API, but how do you ensure the coherency across the internet scale?
How do you keep the databases in sync? Yeah. That's the value of Hashgraph. It does it for you. So it's distributed consensus, right? The Hashgraph algorithm, the whole reason it exists is to ensure that those data structures are consistent and quickly, and that the community agrees that they're consistent, right? It solves exactly that problem.
Mance, thank you very much. So just want to draw this session to a close, and just want to say a big thank you to the 6 presenters today in this room. There's a considerable amount of effort has gone into these presentations over the last month or so, and I shouldn't underestimate the contribution they've made. So once to you all, thank you very much indeed.